Okay, so we're going to be using JPA in the context of a Spring Boot application. Spring Boot application is it's just a a simplified version of the Spring MVC framework, which is very popular in the Java world. And although it's a very complicated framework, Spring Boot tries to simplify the world for us to get something started, very quickly. And I believe we had asked you to download, install, and configure some of these tools already. So you should be all set to go. We did create a project last week, right? And played around with it. So we're going to be using that still. We also configured the database pointing to a local database with a username and password. But a couple of things that we skipped over is that in the application.properties file is where we do all the configuration of the database. There's quite a few properties that we might just hold on and explain what they are. Okay? So a couple of them that we talked about was being able to configure what was the connection string that connected us to the database, right? This solved one of the issues of using JDBC. In JDBC, we hard-coded. We used to hard-code the URL right inside of the string inside of the code, and we criticized that. We said, what the problem is of that, right? If we want to be independent of the database, it makes no sense to hard-code, vendor-specific configuration right in your source code. Ideally, you would want to do that outside of the source code. Right? So here's where we're doing that. Also, username, password, any authentication also would be configured outside. So we're solving those kinds of issues. Another big issue that we are solving here using the Spring Boot and also JPA is that if you notice last time when we implemented our data access objects, we were creating the connection, and when we were done, we were throwing it away. We were closing it, right? And then we would create another connection, and then we'd close it again, right? And I mentioned last week that database connections are very expensive, right? These are resources that take a while for the database to spin them up and configure them, creating a session and logging you in and mapping you to an authority and whatnot. Okay, so typically you would try to avoid doing this, right? Of creating and destroying these connections. So what typically ends up happening is that JDBC has a version of these connections what are called pooled connections, right? So that meaning connections that can participate in a pool. Right, that what happens is that when you run them in a server, typically what will happen is that these connections are created at boot time when the server starts up, and then you would start up with 10 connections to a database that are ready to go, right? And whenever you ask for a connection, a new connection would not be created, but a connection would be requested from the pool if there are any connections available from the pool, ready to go. They're already connected to the so your thread, when it asks for a connection, it would not be created from scratch, but it would be taken from the pool. Okay? So the thread can start communicating with the database right away. There's no lag, and when it releases the connection, it goes back to the pool. Okay? And this works very well. It's perfect for for dealing with hundreds, thousands, tens of thousands of requests that are coming and hitting the server. Simultaneously, and these connections are being shared by these hundreds of threads that are running through the code, right? They take the connection, make a connection to a database, and then release and it goes back to the pool. Usually these pool connections can be configured to start off with maybe 20 connections, right? And when it reaches a threshold, maybe instantiate new connections, right? So that throughout the day, the server can throttle. Right, so that it can adapt with the load as the load changes over the day, during the day, and then at night, as the load goes down, the connections can be released. Right, so it's very efficient. It's very powerful, and it's all done through this JPA and these pooled connections. Okay, the other couple of things that can be configured here is that. You'll find a lot of configurations here that have the keyword hibernate in here. Right? A little history on this is that Sun Microsystems started with JDBC. first came up with a version of this idea of the object relational mapping. They used to call it EJBs, or entity Java beans, and it was a disaster. Everybody hated it. It was very, very hard to use. Had a huge learning curve. It had tons of these event handlers that you had to implement, these lifecycle functions, and it was just, everybody hated it. So Hibernate, a company on its own, created a separate version of an ORM, right? That addressed a lot of the complexities that Sun Microsystem had introduced, right? So it says, we're not going to use EJBs, right? You just give us a class, you annotate it with a couple of annotations, and boom, we'll do the rest, right? We'll do all the magic behind it. So you don't have to, very little configuration, very opinionated, right? So most of the default behavior was already baked in. Only when you wanted to have something customizable, then you would have to tell it and configure it, as opposed to EJBs. You would have to configure everything a priori. Eventually, Hibernate, had a huge following, became very, very popular in the Java community, and so Sun Microsystems sat with them, and they designed the new version of the EJB standard, and it's what's today JPA. So JPA is heavily based on what Hibernate came up with years and years ago, right? And so now Hibernate just happens to be one of the vendors that provides or implements the JPA standard, right? Because it's their standard. It's what they came up with. So anyway, so you will see Hibernate in this keyword, the keyword, several of these in there. They're still kicking around. One of the things that we're going to configure here is that we can configure the JPA to do some magic for us. We can say, hey, take this Java class, right, and magically create the schema for us, right? It can go both ways. You can say, take the Java class, right, and create the relational schema for us, or vice versa. Take the schema that you have over there, right, and generate the Java classes for us, right? It can go both ways, right? You can generate source for you, either starting from Java down to the schema, or from the schema up to Java, right? So it's very, very nice. And the idea is that it wants to create a mapping between these two worlds, right? And sometimes this mapping is not clean, right? It's not one-to-one. So oftentimes you have to step in, right, and say, no, that's not what I want. I really want this or that or the other, because there is no one-to-one mapping, right? We already saw that in the inheritance, right, example. So here we have the DDL, right, the data definition language, and says, what do you want me to do? JPA asks. What do you want to do with the schema? Do you want to create the schema? Meaning, do you want me to look at the Java class and create the schema for you, right? Or do you just want me to update it? Meaning, if the schema is already created, right? Do you just want to do like a difference, right? And only look at the differences, and if there's new fields, I'll create only the new fields, right? The problem with create is that every time you start the server, it blows away your tables, right, and recreates the tables for you from scratch. So any data that you had there before is gone. It just drops the tables and recreates the tables. So you have to be careful. So in development, as you're developing and you're playing around with the schema, right, and you don't know yet what the schema is, then create is fine, right? You're blowing it away. You don't have any important data in there. You're just just futzing around. Eventually, when the schema is already pretty stable, and you feel confident that this is the schema that you want in the relational database, you might want to change it to update, right? And it says, okay, well, only the changes, only the differences, and alter the table. Don't drop them, because I might have important data in there. And finally, you can say none, meaning do not do anything, right? The schema is good. I don't want to touch it. Don't touch the schema, right? This is especially if you are interacting with a relational database that has been around for a while, right? I mean, it's a legacy database. You can't touch that, right? It's been around for several years. You just want to interact with it. Nobody's asking you to modify any schema, any nothing, right? You just want to connect to it and interact with it. So None is a very common setting when you are in production, right? Usually in production, you're not touching the schema, you're just interacting with it, right? You're not modifying the schema, you're reading and writing to the tables, right? So typically in production it's none, but in development it might make sense to put it in create or in update. Yes? Other couple of things is that as you are developing, oftentimes it's very useful for to see what JPA. What is JPA actually doing behind the scenes? How is JPA talking to a database, right? So oftentimes we like to see what the actual SQL that's being used to talk to a database. I want to see the actual select statement, the actual update or insert. This is very useful for debugging, right? So if you start getting SQL exceptions and say, well, there's a syntax error here and there. You have an error in your syntax. I want to see what the SQL statement is, right? And you can copy it and then go to your database, right, and paste it in there and try it out. See if there's something wrong with it, right? There might be something that's you weren't. So shows SQL true allows you to debug and see what the actual commands are going, right? Obviously, in production, you would turn this off, right? You want to minimize any additional logs into the server's log, right? That's not necessary. But on development, while you're developing, this is very useful. Also, some naming strategies. So usually, in Java, you have a naming conventions, right? Where typically functions are camel case. They're lowercase at the beginning, and then they're camel case. Usually, all your variables are camel case. Your classes are uppercase, right? And then camel case. So in Java, that's fine, right? Java is a case-sensitive language. Now, all these classes and fields and variables, they're going to be mapped to a relational database, and where relational database has a completely different naming convention, right? It's a case insensitive, right? So usually all this camel casing is useless, right? There is no differentiation between the cases. So typically all these variables and classes and whatnot need to be converted into the target naming convention, which might be using underscores, all lowercase or all uppercase. So you can configure, right, what the strategy for naming conventions you want, right? Maybe you want to abbreviate it. Maybe you don't want it to be more than so many characters, right? So and you can configure that. You can also configure the dialect, right? Meaning, JPA can map to any vendor, right? It can map to to Oracle, it can map to MySQL, to SQL Server, to any Postgres, right? So you can configure what dialect am I talking, right? So that I can convert this high-level, ORM world into the low-level dialect that you want me to talk, right? So it can speak any dialect of any vendor out there, and you can configure that as well. There's a couple other things that can be configured. Add comments, format it for us, trace every single query. There's a couple other things, but we're just going to leave it at that. All right.